So something you're going to see me do today, as you can see on my screen, is I'm going to show you some really cool machine learning projects that I have been working the last sort of 4 to 5 days on. What you can see on the screen here is a Linux container with Prometheus, Grafana, and Telegraph. No NVIDIA SMI because I'm running on an AMD system on chip ZBook, so I'm running an AMD GPU. And you can now see that I'm in VS Code, something that was quite alien to me before I did Harvard's computer science course. I've never done any kind of coding or software engineering. And in VS Code, you can see a ton of files, MD files, Python code files, JSON files. This makes up my entire project stack for a particular project, which you're going to see in a moment coming up on the screen. And this is me using publicly available data sets, creating a machine learning showcase for something called RUL, Remaining Useful Life, of tyres. And that tracks the distance in kilometers that the tyres have been driven and things like tread depth. So being able to run predictive models and predictive analytics on how much life that tyre has left and when it needs to be replaced. And that's just kind of a small high level. So some of the stuff on the screen probably doesn't make too much sense to a lot of people, unless you're a data scientist or a data engineer. But we've created, and I've been able to create this entire project using my knowledge of data science, a magazine that I wrote. I'm not a data scientist, I'm not a data engineer, but with our Agentic AI platform, I've been able to deliver this entire project. So what you can see on the screen is a data design plan. That's something I asked Agentic AI to do. We do data design plans for every single project. And that's really mapping the data estate, classifying the data, checking what variables exist within the data, getting ready to pre-process that data. We're using things like Pandas for cleaning the data and manipulating it, and really understanding what business goals, insights and outcomes can be derived and delivered through that data. So this is a really nice, slick HTML that kind of shows everything. For me, this is where it gets really exciting because I've been able to build a Dash app similar to sort of Python Flask for the entire project. And here you can see model performance. We started with a linear regression at 6%. I then switched it to a random forest. I then enhanced hyperparameters, and we got to 99.5% accuracy. This is all around MLOps pipeline. Is all around efficiency, scalability, and reducing risk. So being able to detect model drift and degradation of model performance. We use things like TensorBoard to monitor real-time accuracy and loss. You can see even without ROC-M, because my GPU is not supported on AMD ROC-M, I was still able to use PyTorch Direct ML to use GPU acceleration, and through that screen you've seen an entire project with costings, an entire business use case delivered by machine learning on how much money we could potentially save companies in terms of understanding when they need to replace their tires and how much life that tire has got in it. So we're moving on to something called Project Aphrodite. This is all around cosmetics. And you're about to see our software Ariadna, which tracks data flow diagrams and data lineage. And it's really important in both projects, Project Vulcan and Aphrodite. I've built an enterprise class data warehouse with a full ETL pipeline, ingested all of the publicly available data into that data warehouse. And you're seeing now how that data is actually mapped. So we've got some really cool stuff going on in this dashboard that you're now seeing. It's an entire unified app, which is built in Python, Dash app or Flask. And this again shows you all of the different models, machine learning models, that I was able to run, the best model accuracy of 96.5%. And you'll see a ton of other stuff on the screen, but I think it's really important to kind of talk to you about the fact that, I'm not overfitting my models. I'm not deliberately retraining and training the data or training the model on a training set so it does really well when it sees data that it knows. But actually, the more that you do that, it kind of degrades the model's ability to seeing underlying patterns in new data. So that when you get new data, that model accuracy, let's say it's 80%, when it starts to inference on data it's never seen before, all of a sudden your model accuracy drops massively. So I've been really careful to create training sets and hold out validation sets where I can train the model and then I can validate the accuracy of the model on data it's never seen before. And this is an entire machine learning project delivered by me. As I say, I'm not a data scientist, I'm not a data engineer, I'm not a data analyst. I do know a lot about it. And with our Agentic AI solution, I was able to guide it through the entire project to deliver something absolutely cutting edge. I would say for people that don't know too much about Agentic AI, we have a piece of IP and governance framework that all of the agents must adhere to, because you'll get agents that will tell you that they've done something, they'll validate it, they'll tell you a whole list of things that it's done, and if you don't know any better and you don't check, you won't know that it in actual fact hasn't been done at all. So there are limitations to Agentic AI, but the power is unreal.